Hello and welcome to yet another one of these movies. Now, in this one, I'm going to take a slightly different tack. In the previous one, I wanted to give you live music as quickly as I could. That's good in terms of hopefully enthusing you that live coding is something we can do to start producing music quite quickly without having to learn a whole lot. But sometimes you want to take a step back and say, we're going to learn something which isn't immediately quite so applicable to create all sorts of wonderful music, but will give you skills that in the long term will really, really help you take a lot of control over the music you're creating. So let's start Sonic Pi, wait for it to start booting, etc. And eventually we'll get the Sonic Pi workspace in front of us and we can start doing things. I'm going to quickly just repeat what I did last time. So let's play a 60, let's sleep for 1, play a 64, let's sleep for 1 again, and play a 67. So if I play this, we should hear some music. And there we go. Okay, now the first thing I want to point out is that a 64 is what's called a constant. A constant is something which never changes. The value of 64 today is 64. The value of 64 tomorrow will also be 64. And if we wait long enough that the sun has actually blown up into a red giant and burnt the earth into a crisp, the value of 64 will still be 64. Okay, 60 is also a constant, 1 is also a constant, etc. So, what can we do? Well, as well as having constants here for our arguments to tell our play which number to play, we can also have what are called expressions. So I'm going to change this slightly to make it 60 plus 4. The value of 60 plus 4 is 64, so we'd expect it to play back exactly what it played back previously. And I'm going to do this as 60 plus 7. I don't need to change that, but just make it nice and neat. And if we play it back, we should get exactly the same result. Okay, I'm just going to slip into buffers and look at these what are called expressions. A constant is just a number, for example, and an expression is where we put constants and other things together using operands such as plus, minus, multiply, etc. 60 plus 4, it knows to calculate that expression and get the value of 64 before it calls play to actually play the note. So this actually played the note 60, then the note 64, which it calculated, and then the note 67. I'm going to switch quickly to buffer 0, from buffer 0 to buffer 1, and here I can type in some more things. So I'm going to put play 60, I'm then going to put play 30 times 2. Note the multiplication is a star because x is actually a letter. So we use star for multiplication. Play 28 plus 32. And we're going to finally play 4 times 3. Oh no, let's make it 8 plus what am I doing? Okay, here we go. Play 7 plus 8 times 4. And finally I'm going to do play 10 plus 5 times 10. Let's see what this sounds like. Each one of those notes was exactly the same because 60 has got the value of 60, 30 times 2 has the value of 60, 28 plus 32 has the value of 60, 7 plus 8 is 15 times 4 is 60, and finally 10 plus 5 times 10. Well, because of BODMAS, remember it does the multiplications first, it multiplies 5 by 10 first and gets 50, then adds 10 to it and gets 60. So all of these expressions here actually all add, multiply, etc. up to 60, and that's why all the notes sound exactly the same. Okay, so expressions are very, very useful because it means we can tell play to play something that we don't immediately know the number, but we have to somehow calculate it. If we come back here, I have some very, very simple expressions. 60 by itself is an expression. It's just the number 60, so it's got the value 60. 60 plus 4 has an addition, and it adds 60 to 4 and gets 64 and plays that note. And 60 plus 7 again does that. So what can we do with this? Well, these are what I call constants. They never ever change their values. We can also have something called a variable. And a variable is something where we can store values which can change their values later on. So at the moment I have a variable called base, and it has the value 60. If I use base, its name, instead of a number, it's exactly the same as if I use the number that's stored in it. So if I change this base, this number 60 to base, because base is like a little box storing the value 60, if I play base, I play the value stored in it, which is 60. If I play base plus 4, then it takes the value stored in base, which is 60, adds 4 to it, and then plays the value 64. And then if I play base plus 7, it takes the value stored into base, which is 60, adds 7 to it, and plays that back. So let's hear what that sounds like. So it played the numbers, or played the MIDI note numbers, 60, 64, and 67. So over and above having these expressions, we can also use what are called variables. Variables can be changed by assignment statements. So take a value and store it into the variable name. If that variable doesn't already exist, then it automatically gets created. And I can actually have more than one of them. So if I have another one called third, then if I add base plus third, it will take base, which is currently storing 60. It will take third, which is currently storing 4, add them together, give me 64, and that's the note that will then be played. Okay, so why are they called variables? Well, in actual fact, they're called variables because we can change them. They're not constant. They don't stay the same forever. They can change whenever we want them to. I'm going to cut and paste that code, so you see this bit of code here gets played twice. Once there and once there. I'm not doing anything after I set its initial value to change the value of base, so it stays at a value of 60 all the way through, and the value of third stays at its value all the way through. So let's run this and see what we get. Okay, but I could, if I wanted to, here change the values. So I'm going to change the value of base to be 62, and change the value of third to be 3 instead. And let's see what we get now. So this is actually playing a little tiny arpeggio, which is C major, and here we actually play a D minor arpeggio. The code is exactly the same, but because the value of base has changed its value, it was originally 60, and now it's gone to be 62, this code will then give us a different result because the values of these expressions will be different. Base is now 60, so 60 plus is now 62, so 62 plus 7 is 69, and that plays a different note. It plays an A, actually. And base plus third, base is now 62, third has changed its value and is now 3, and so therefore 62 plus 3 will give us 65, which is actually a F, is the F. Okay, so that's one way we can do things. We can actually also change these things a little bit in different ways. I'm going to say base equals base plus 9. So that's what's called an assignment statement. It's taking the value of the variable and it's changing it. Over the right-hand side, we have an expression that we calculate. Base is initially 60. 60 plus 9 is 69. And then once we've calculated the 69 over the right-hand side, that's the value of the variable we change. So base is going to change its value with that assignment statement. The third just goes to be 3. If we play this music back, we'll see what we get. And this here will actually play a C major chord as we did before, but because of these modifications of the variables, this will now actually play a minor chord. So that's actually quite a bit on variables, and they're very, very useful, but this is just a brief introduction to them. We will use them in much more sophisticated ways in later movies, but I do actually want to change things a little bit here. Previously we had this. We had the ability to loop something. Okay. And what I'm going to do is if I loop it like this, it will just keep on playing exactly the same C major triad over and over again. That's because this code is being repeated and the value of the variables are never changing. If I put my assignment statement, which is the one that can change the value of a variable, in here, then it'll play the code once, then change the value of base. Base is a variable, it can change its value. If base was initially 60, then we take the 60 plus 2, that gives us an expression value of 62. Then once we've calculated the value on the right-hand side, we go over to the left-hand side and change the value of the variable. I can put in a very useful print statement. So I can see over here what's happening to the value of base. Let's play this and see what happens with this loop. Base is now 62. Base is now 64. Base is now 66. And it will keep on going up forever. I'd better stop it because otherwise it'll keep on going forever, base will keep on getting higher, and eventually it'll be beyond the limits of human hearing. So, if I wanted to do this but only repeat it 4 times, what would I do? There is going to be a movie later on, much more about loops, but instead of using loop, I can use for.times do. If I run this loop, then it won't repeat forever, it will only repeat 4 times, which can be very, very useful, because quite often in music we want to repeat something a number of times and then go and do something different. So, let's see what happens if I run this. Okay, so that's interesting. I could then copy this entire loop here, repeat it, also repeating 4 times, except to say that instead of the value of base going up, it's now going to go down. Base equals base minus 2. If base is, say, 68, which it finished on, 68 minus 2, if we use the variable, it's the same as if we use the number stored in it. 68 minus 2 is 66. Base goes down to 66. Next time around, base equals base minus 2 if base is currently 66. 66 minus 2 is 64. That becomes the value of base. And so therefore we get music which goes up with the first loop, which repeats 4 times, and then goes down with the second loop, which repeats 4 times. Let's play this whole thing and see what it sounds like. And there it is. Because of the way we wrote this, it doesn't actually do the 50 at the end, or this doesn't go back to the C at the end, so I'd probably make that 5 times. Okay. But the one thing I'm going to change before I finish is I'm going to say reps equals 4. Anywhere I use a number such as 4, I can use a variable storing a number. I'm going to change the reps to be 5 actually. And if I put reps.times, that means I'm using a variable to control the number of times I loop. Okay, let's see how that works. And I'm just slightly frustrated that it didn't actually play my C at the very end. My music feels incomplete. Anywhere that I use a variable, I can use an expression. So if I go reps plus 1, and reps has the value 5, the value of reps plus 1 is actually going to be 6. So this loop is going to repeat 6 times, and that should take me all the way back down to the bottom again. I'll change reps to be 3. Okay, and this means that it will repeat slightly fewer times. Let's have a look and see how that works. And there we go. So basically, that's quite a bit of coding there. We've got our variables. We're able to play around with our variables using assignment statements that change their values. We're able to use those variables instead of numbers, both just as an argument to play, and also in expressions that calculate values. So there's quite a bit going on here. I would recommend that you play around with producing a bit of your own music just using simple variables and expressions. Start again with writing some code that doesn't use any variables or expressions, just straight numbers. Modify it to use a variable and play around with the variable at the top. Do something different from what I've done, so you're really experimenting. Then try playing around with the expressions, and then maybe try and use some of these loops. I'll start off with just using loops that repeat a certain number of times, and then, if you're feeling really adventurous, play around with using variables or even expressions to control how many times your loops run. Using the print statement, I can put things inside quotes and they just come out as they are. Comma and then a variable that actually prints out the number that's in the variable. Example here, after the end of our code, base ends up having the number 58 in it, which is useful to know. And by playing around with these things, you'll start getting used to the basics of coding. Just a very small number of tools here, but enough to actually do some interesting things. Because remember, here I'm just using play, and I'm just playing things back with a very simple sine wave. But we can use sample commands to play back samples, which makes things more interesting. And we can also do more interesting synthesis in the future in Sonic Pi. And both of these things will allow you to take these, how would you put it, coding strategies, coding techniques, coding commands, and do more interesting things to them. Note that if you look down the bottom, if I switch help on, then down the bottom we have a whole lot of help about how to do things. This is quite a different way of learning Sonic Pi. I do recommend that you both use the help and watch the movies. Some people prefer movies, some people prefer text help, but I find that quite often people learn best by using a variety of different techniques. So you can have a look at live coding and start learning by the help files, start learning through my movies, and start learning particularly through your own experimentation and trial and error. Put all of those together and there's a lot of support to help you learn Sonic Pi. So note the help, I can switch it on and switch it off in order to give myself some more space. Also the scope at the top is quite useful because as well as hearing sound, we can see it as well, but if you don't want the scope, we can switch that off. And if you go here, you can actually give the scope and everything else more or less space. Okay, that's enough for this movie, so that's the end of it, and I'll see you in the next one.